All right. So we want to do problem one in problem one or in set 1.3. So I need to find a linear combination of things that equal B. And then I want to write B as a matrix vector multiplication with 3, 5, 4, and X. And then compute the dot product. So, whoa, that's a whole bunch of instructions. Is that what happened, Jordan?
Probably. Yeah, I was getting confused by exactly what it wanted me to do.
Yeah, Strang has a habit of asking questions with kind of several parts. It is totally okay. It is totally okay to have kind of memory overload on some of these. You just start reading again at the beginning and see if we can straighten out where we're at, right?
Like, I found B and I checked the solutions manual and that was chill. But then, like, the next half of the problem, I'm like, I don't know.
Okay. So let's look at this part over here, right? So finding the linear combination of these things. So I want 3 times S1 is 1, 1, 1, plus 4 times S2 is 0, 1, 1. And then I'm supposed to find 5 times 0, 0, 1. Everybody with me on this? And this is supposed to equal some vector B, right? Well, I feel pretty confident that I can multiply scalar-wise in here. So I'm pretty confident that when I multiply 3 times 1, 1, 1, I get 3, 3, 3. What do I get for this second vector?
0, 4.
0, 4, 4. And for the third one?
0, 0, 5.
Good. Okay, and then you stuck the x coordinates together, so you got 3 and 7 and 12, presumably. Everybody bored to death with that? Okay, cool, good. All right, then I'm supposed to write B as a matrix vector multiplication Sx. Okay, so I'm just trying to parse through this with my brain, right? B as a matrix vector multiplication Sx. So to me that says B equals Sx. Okay, but I know what B is. It's 3, 7, 12. You guys all with me on that? And then they tell me to write X with 3, 4, 5 in it. So this is going to be S times 3, 4, 5. And then I want to go back over here and I look at this and I think two things. Two things I think are, that's a linear combination, right? And it's also the column picture of matrix multiplication. You guys with me on that? Anytime you see a linear combination, you can think, oh, that's a matrix times a column. You guys good with that? So I think that I can rewrite this as this is 3, 7, 12 is the matrix S, whatever the hell that thing is, times the vector 3, 4, 5. And then which things am I linearly combining? Combining? What the hell you say that word? What were the vectors I was combining?
S1, 2, and 3.
Mm-hmm. And those are, because those are the ones that I'm combining, they are the columns. So this first column is 1, 1, 1. The second column is 0, 1, 1. And the third column is 0, 0, 1. You guys see that? And now, if I have this thing, I can think column picture. right? So if I grab this guy. So I can have two thoughts from that. One, I can think column picture. Right? Where it's a linear combination of the columns. The other way I could do it is it with the row picture. And that's what they're asking for in this part where they say compute the 3 dot products of the rows times x. So what are the rows of this matrix? So what's row 1 in there?
1 0 0.
Good. And this is where I'm going to have a problem with notation, right? Because I want to think about that row as a vector, so I can do a dot product, right? So I'm thinking that's a row like this, which you guys might think of this way. You guys see that? This is what's called a row vector. I'm going to continue to write them with these angly brackets, but if you watch videos of other people talking about this, you might see these. They just mean the same thing, right? They're just a vector. This book reserves the word vector for vertical, like column vectors. And I think that's the right approach to take, but be aware that those exist in videos. What's row 2 then?
1 1 0.
Perfect. And what's row 3?
1 1 1.
Perfect. Okay. And now if I take the dot product of R1 dotted with 3, 4, 5, right, my x vector, I'm going to get 3. If I take row 2 and dot with 3, 4, 5, what do you get?
Okay, since you danced, I'll answer. 7.
Thank you, Grayson. These videos are going to be super embarrassing later. Whatever. All right, so if I take row 3 and dot with 3, 4, 5,
12.
perfect. And then notice that 3, this 7, that 7, this 12, that 12. Because the row multiplication picture and the column multiplication picture give you the same answer. They're just different perspectives. You guys with me on that? So then if I'm answering this question, right, I'm going to say, okay, so this part's the linear combination. This is the matrix multiplication equation, right? The matrix multiplication. And the row dot products are these 3, 3, 7, and 12. You guys all okay with these? Okay, hearing none.